All right, so this is a video on lesson 2.1, rates of change in tangent lines. So basically, this is the development of what we're going to talk about what derivatives mean. So this is a super important concept. And so in geometry, we talked about the secant line intersecting a circle at 2 points, and then a tangent line. You had a bunch of theorems when you took geometry about a tangent line being perpendicular to the radius and some of those things. And so those were some theorems that you had, those circle theorems you would have had in geometry. And so we learned that a tangent line intersects at only 1 point. And so we basically have that idea about a tangent line to a curve. It's just we have to have a little bit of a different definition to that. And if we look at the figure, we can see, like if we look at this picture, so the line that's drawn there is not tangent at Q, but it is tangent at P. So we can't give a definition of it just intersects at 1 point, because clearly this line intersects the curve twice, but it can still be a tangent line. So what we basically say is a tangent to a curve. So this is kind of an important statement here. A tangent to a curve at a point is the line that best models or approximates the behavior of the curve at the point. Okay, so we will actually talk about the slope of that tangent line being what we call the slope of the curve. Okay, so that's actually how we're going to talk about it. So the tangent line is what best models right there at that point. So really close to that point is what we're talking about. So the curve could be curvy, but really close to that point, the line is going to approximate that. Okay, so again, this idea will help us find what we call the slope of a curve at a point. And so there's many things we call it. We call it the slope of the tangent line, we call it the instantaneous rate of change, or the derivative. So all of those things will be talked about many times. And so that's kind of important to know. Those are terminologies we use, and those are the different terms that we will say. So the tangent line at a curve is unique. There's only one tangent line at any specific point to a curve. And if we look at this figure, we would say that the point of tangency is the point A, f of A, of course A being the x value and f of A being the y value. So we say that that point is the point of tangency, and the slope at the point of tangency is written f prime of A. That's how we read it, f prime of A, and it's written f with the prime symbol of A. And so that is really important, and there's only going to be one tangent line at a point. Now, the way this sort of all comes out and develops is we're going to draw something in a second, but basically what we call the average rate of change, and I prefer you don't do that you don't write that. So I would prefer you can abbreviate a little bit. You can say av rate of change, but I don't like for you to use abbreviations because that's not necessarily standard. So let's just write average rate of change. Well, the average rate of change over an interval, you've known that since middle school. That's called slope. And these are the different ways we can write it. Change in y's, or delta y over delta x. We say m, like for slope, which you've done forever, and the little sec is just saying the slope of the secant line. So that's the average rate of change. And of course, the normal way you find the slope, f of b minus f of a over b minus a, or the y minus the y over the x minus the x. Okay, so that's what we're talking about. So a way to find the average rate of change over an interval, we would write, so if I want to find average rate of change, okay, is going to equal, so I'm going to do, if I'm going to do for the function f over the interval 3 to 1, then I would write f of 3 minus f of 1 over 3 minus 1. Okay? And then I could just do the arithmetic. I can plug numbers in if I feel like I need to. I could do the arithmetic to the side if the numbers are big. If the arithmetic's easy, I would just do it here. So I just look at the function right here, f of x, and I imagine plugging in 3. So 3 cubed would be 27 minus 3 times 3, so that'd be 27 minus 9, which would be 18 minus f of 1. And if I plug in 1, I get 1 minus 3, which is negative 2. So that's 18 minus negative 2 over the 3 minus 1, which is 2. 18 minus negative 2 is 20 over 2, which is 10. And again, as many steps as you need there. So that's the average rate of change. Okay, so that hasn't changed. Average rate of change means slope. Same thing you've always talked about forever. Now, let's talk about instantaneous rate of change. Well, we can't just do the tangent line by saying, okay, we'll do f of a minus f of a over a minus a. Well, we would get 0 over 0, and you can't actually say that. You should never write equals 0 over 0. So we can't do that. So what we're going to do is we're going to change our method here. And so what we're going to do is we're going to say, okay, so instead of putting the points right next to each other, we can't do the same point. So what we're going to do is we're going to pick 2 points that are close together, and we're going to draw a secant line. Okay, so there's the line. And so you have the point P, which is at A, f of A, and you're going to have the point H, or the next point Q is actually it's at A plus H, because that's how far that is, and f of A plus H. Okay, so there's going to be my 2 points that I have. So that's the way we're going to have the points. Well, what we're going to do then is we're going to say, okay, what would the slope be? So the average rate of change here, if we were to do that between those 2 points, the average rate of change would be f of a plus h, because that's the second point, okay, because h is that point there, so we have f of a plus h, and then we have the x value is a plus h, so the y is f of a plus h. And then we're going to subtract the y value for the first point, which is f of a, and then we're going to divide that by the x, which is a plus h minus a. Well, that's going to simplify to f of a plus h minus f of a over h. Now, you've seen this before. We also called that the difference quotient. Okay? Now, what we're going to do for calculus is we're going to say, but that's not the slope that I want. That's the average rate of change. So for calculus, we're going to say, okay, well, what if h moves and is closer and closer and closer together? So actually, this point's not h. This point's a plus h. H is actually the distance right here. Sorry, that diagram isn't right. So h is actually how far apart they are. Okay? So I'm going to have h be, h is this distance right here. That's how far apart the 2 points are. So the second point is actually at a plus h. That's the reason that's f of a plus h. So that diagram's just not written right. And so h is the distance. Well, what I'm going to imagine is, so let's say, okay, so what if the 2 points were closer together? So this is an average rate of change, but maybe I'm trying to find the instantaneous rate of change right there at A. So I actually want the slope of this tangent line that's at A. Well, that's kind of close to the tangent line, but what if I moved H and H was smaller and I moved to a closer point? And now I connected the 2 lines. Well, that's actually a little bit closer to the slope that I would have right here at A. Like if this is actually the tangent line that I'm interested in, if I just move the point closer, that slope is better. It's better than the red one. The green one is. I'm just making H smaller. So I'm just going to let H keep moving towards A. So let's move even closer and draw a tangent line. Well, that one's even closer to the actual tangent line. And if I move even closer and I draw the tangent line, then I'm even better. So the closer and closer and closer I get, the more the line starts to look like the tangent line. So what we're going to actually do is we're going to use limits here, and we're going to let that distance between those points become 0. So remember, that's what limits do. So the slope of a curve at a point is simply going to be the limit as h goes to 0 of that difference quotient. So the f of a plus h minus f of a over h is simply a slope of a secant line. H is the distance between the 2 points. I'm going to let that distance approach 0. So now that is going to be closer and closer and closer together until it would be the tangent line, right? If the distance was 0, then I would be there. Well, that's what a limit does. Remember, it talks about what would happen if I could let that be 0. I can't, because I would get 0 over 0. But I have to think, okay, a limit tells me what would it be if I filled that in. So this is part of the reason why we had to learn that. So in algebra, you did a lot of difference quotients, and you did the f of a plus h minus f of a over h. So I'm actually not going to do that. So the bottom of that page that you're on, where it says using a difference quotient, we're going to skip those examples. And we're actually going to go to a calculus problem, which is we're going to use the difference quotient and find the slope of the curve at the point. Well, what that means is if I want the slope of the curve at the point, then what I'm wanting to do to find the slope is I have to take the limit as h goes to 0 of f of x plus h minus f of x all over h. That's the definition of the slope at a point. Now, we're going to do the slope at a very specific point, so our x will actually could be a number if we wanted it to be, but let's do the generic formula, okay? So we're going to solve this with an x in it, okay? So we're just going to find that value. So for this particular function, so let's do this limit. So f of x plus h means put x plus h in here for x squared. So that's x plus h whole thing squared minus f of x, which is just x squared. If there had been more than one term, be sure you do minus parentheses, okay, over h. Now, a lot of times what I would do is I would go over to my scratch area and I would do x plus h squared. And I would actually do the simplification here. This one isn't too bad, but I'm going to go ahead and do it over here. So I'm going to get x squared plus 2xh's plus h squared. Remember, you're squaring a binomial. If you can't do that without writing it, then you write out x plus h times x plus h. And now you can distribute and do all that, and you'll get that written down. So I'm going to come back over here, and I'm going to fill in what happens when you square x plus h. So you get x squared plus 2xh plus h squared, and then minus the x squared, that's this part, just coming down here, all over h. Well, let's simplify things a bit. So what do we notice here? Well, we notice that x squared minus x squared, right? Those will go away. So I will end up with 2xh plus h squared over h. And then remember, we've practiced this when we did our review, but you can factor out what you're technically doing is factoring out an h in the top. So you have 2x plus h all over h. And then now that you have multiplication here, you have h over h. That becomes a 1. So you really have the limit as h goes to 0 of 2x plus h. Now apply the 0, which of course means plug in, or apply the limit, which means plug 0 in for h. You plug 0 in for h and you're just left with 2x. Well, what that gave us is the generic formula that gives us the slopes for all the tangent lines to x squared. So this is for all the different points. This is the formula that gives us the slope. The question says, find the slope of the curve at this particular point, 3, 9. So that means the answer to my question is, and here's a way that you can write that. There's a lot of things you can do here. You can say, I want the slope at 3,9. So you could say at 3,9. You could also say slope, comma, 3,9. That's just a way to tell me, hey, I'm finding the slope there. The slope is going to be 6 because you're just going to take 2 times the 3. So therefore, the answer is that the slope of the curve at 3,9 is 6. Okay? Now, what we're interested in a lot of times is writing the equation of the tangent line. So you can either write the slope this form, all they've done there, this is the point slope form, remember? If you want, you can always remember it as, instead of minus y1, you can always just put plus y1 on the right. If you start messing up your signs, just go back to the point slope form because it's perfectly fine. So I'm going to do the point slope form. So I have y minus the y value, which is 9, equals the slope at that point. Well, we just found the slope was 6, and then we have x minus 3. So the answer that you should give is this answer, or the most you should ever do not distribute that, just simply put plus 9 on the end. Those are the only ways that you should really ever write an equation of a line. The only reason to change it is if you're trying to match and all the equations are in a different format, okay? Then you can distribute and change it. Otherwise, you should leave it. Okay, you should definitely not change it. Okay, so let's talk about vertical tangent lines. So the problem with a vertical tangent line is the slope doesn't exist, because if you have a vertical tangent line, you have it's straight up and down, it's vertical, so the slope does not exist. It's undefined. There's no definition for the slope there. Well, a vertical tangent line, we will know that we have a vertical tangent line if we do the limit, we try to find the slope, and we get plus or minus infinity. So if we get that answer for the limit, so we don't get does not exist, we get specifically, remember how I said technically infinity means the limit doesn't exist, but this is stronger, so we like to go ahead and say this. So if you do the limit and you can answer either positive infinity or negative infinity, then we know there's a vertical tangent line there. Okay, so that's just an important distinction. A limit that doesn't exist for that does not mean that you definitely have a vertical tangent line. It has to be infinity or minus infinity. Okay? All right. I'm not going to speak a lot about the normal line because the normal line is actually not really on the AP test, but you do talk about normal lines in physics, so you should sort of remember about normal forces, and a normal force is perpendicular. Well, a normal line is simply the line that is perpendicular to the tangent line. Okay, so that's a different thing we could find. We could find the normal line is what that means. Okay, so that's all we have there. So we're going to go ahead and do part of example 6. We're just going to talk about the, we're going to use the limit definition, and we're going to see how to do this algebraically. We're not going to spend a lot of time on that because there's better things we can do, but I'm going to go ahead and show you this one algebraically, and then we're going to find the slope of the curve and then write the equation of the tangent line, and then we'll talk about how you would just do quickly the normal line. So the limit definition of to compute the slope means that I have to do the limit as h goes to 0 of 1 over, I'm going to substitute x plus h, and I'm going to go ahead and put a in there because sometimes students get confused. It doesn't make any difference. It's a or x. It's just at that place. It's a plus h plus 3. So I'm putting a plus h in place of x, okay? Minus 1 over, I'm placing a with x. So the reason I'm using a is I'm saying let's do it at x equals a. Okay, so we're putting a in place of x, and that's all over h. And so that's the formal definition, f of x plus h, or a plus h. So I'm substituting a plus h in place of x minus f of a, so just put a in place of x over h. Now I need to simplify this because I clearly can't do this limit. You can try it, but as h goes to 0, you're going to get 0 over 0. So a technique to use would be to get a common denominator for that numerator to add that whole thing together. So what I'm going to do is I'm actually going to pull out this h down here because it's actually 1 over h times this whole thing. So I'm going to pull that 1 over h out because it makes life easier. And now I'm going to simplify the top, the part that I kind of put in those red parentheses. So to do that, I'm going to get a common denominator. Well, neither of those denominators has any factors in common. Factors are things you multiply together, not add, so they don't have any factors in common. So that means I need to multiply by the other factor. So in other words, my common denominator here is a plus 3 times a plus h plus 3. That's my common denominator. Okay, so that's what I'm going to have on the bottom. And the top is going to be, well, if that's supposed to be the new bottom for this denominator, then that means I'm going to, for this denominator, I need to multiply by a plus 3 over a plus 3. So I'm going to get an a plus 3 up there, minus parentheses. I'll have to multiply this one by a plus h plus 3. And that's going to give me my fraction. Now, if you need help with fractions like that, absolutely just ask in class, say, hey, can you help me remember how to get common denominators and do some of that. So now all I'm going to do is simplify the top. So I have a minus a, so that's going to go away. I have 3 minus 3, because I'm going to distribute that. That's going to go away. So then I'm only going to have minus h in the top there. So I have minus h, and in the bottom I still have the a plus 3 times a plus h plus 3 is still written. Okay, now I'm going to simplify. Well, this is a product, so h and h will go away. This doesn't leave nothing, that leaves a 1, because there's a 1 there. So the top is -1. I still have a limit. I still haven't finished the limit yet. That's just simplifying. Okay, as h goes to 0, I have a -1 on the top, and the bottom has a plus 3 times a plus h plus 3. And then now I can do the limit. So the limit is to let h go to 0. So now I can plug in h going to 0, and I have -1 over a plus 3 times a plus 3, because h is going to 0, or -1 over a plus 3 squared. Okay, so that's the formula for the slope. Okay, so that's the slope at any point A. B says find the slope of the curve at x equals -1. Well, that means the slope at -1 is going to be simply plug -1 in. So it was -1 over -1 plus 3 whole thing squared. So that's going to be -1/4. So that's the slope. So now if I want to write the equation of the tangent line, I'm almost there, but I've got to find the y value to go with x equals -1. So let's go back to this. I need to find, for this function, what is f of -1. So I'm going to write that here. In other words, f of -1 equals, and so you're going to have 1 over 2 when you plug in -1. So that means the tangent line at x equals -1 is going to be y minus the y, which I just found to be 1/2, equals the slope, which I just found in part B, times x minus the x, which would be x minus -1, which is x plus 1. And then you can just absolutely leave the answer like that. You can also write it with plus 1/2 on the right instead of minus. Now let's just very quickly say, let's find the normal line. The only difference to the normal line is the normal line simply is perpendicular. So if it's perpendicular, remember their slopes are opposite reciprocals. So the normal line is going to be y minus 1/2 equals, so the only difference in the slope, flip it and change the sign, 4 and then times x plus 1. So that's all there is to finding the normal line. Everything else is the same point. And then they say use the equation that we found in part C to estimate what happens at negative 1.1. This is actually going to be a very common thing to do. So all I'm going to do is write that equation again right here with that negative 1/2 moved to the right. And we want to find y of negative 1.1 because we're just estimating the value. Or you can write f of negative 1.1 to find that. Actually, we want to do we're estimating f of negative 1.1. That's going to be approximately equal to what happens when I plug negative 1.1 into y. So it's going to be approximately y of negative 1.1 because y is the tangent line, f is the function. So y of negative 1.1 would be negative 1/4 times negative 1.1 plus 1, which would be negative 0.1, then plus 1/2. And so here's a time where decimals might be better. So negative 1/4 is negative 0.25 multiplied by negative 0.1. So negative times negative is positive. So over here, let me just write negative 0.25 is going to get multiplied by negative 0.1. So you're going to get 25. And then you have 3 decimal places, so you have to add a 0. You get 0.025 plus 1/2, which is 0.5. So this ends up being 0.525. Okay, and so that's your estimate. That's going to be important later. We'll talk about that a lot. Okay, and we're not going to do the last example. We might do part of that in class, but that's it for this set of notes.